Hi, I'm Mr. Hooper, and in this video we're going to talk about exercise 1D. Let's see whether this equation is also an equation quadratic in 3 to the x or something like that. Okay, so let's start off. 3 to the 2x times 3 plus 3 is equal to 10 times 3 to the x. Well, 3 to the 2x times 3 to the 1 again. This can be written as 3 to the x to the 2 times 3 plus 3 is equal to 10 times 3 to the x. Now you can rewrite this as 3 times 3 to the x to the 2 minus 10 times 3 to the x plus 3 is equal to 0. And now you can clearly see that it is a quadratic equation in 3 to the x. This is not a quadratic equation, but it is a quadratic equation in 3 to the x. So let's substitute that. Z is equal to 3 to the x. So 3 times z squared minus 10 times z plus 3 is equal to 0. So let's use the formula. This is 10 plus minus the square root of 100 minus 4 times 3 times 3 over 2 times 3. So this is 10 plus minus the square root of 64 over 6. This is now 10 plus minus 8 over 6. So 18 divided by 6 is 3. And 2 divided by 6 is 1/3. So Z is 3, or Z is 1/3. So now we need to resubstitute. So 3 to the x is 3 to the 1 if you want. So x is 1. And 3 to the x is equal to 1/3. So 3 to the x is equal to 3 to the minus 1. So x is minus 1. So the solution set is plus minus 1. So although this equation looks very difficult at first, once you rewrite it and you make clear that it is a quadratic in 3 to the x, you substitute, then you work out z, you resubstitute, and you work out your solutions. So it's not a quadratic equation, it is an exponential equation, but you can write it as a quadratic equation in 3 to the x. You can substitute it and work it out. Hope it wasn't too difficult. See you in the next one.